Okay, so we are going to do string functions and some more functions, important functions today. If your data is in string form, then you should know these functions, how you use them. Okay, so very simple functions are there. So let us have some string, and we can do first will be to capitalize. I have already put the functions here. So if something is missing, I'll put it. Not all are here. Okay. So what is not there, we'll be seeing it here. Okay. So let's have string. Welcome to the world of beauty. Okay. Now let's capitalize that. CSTR capitalize. You just have to do it directly. Okay. So str is there. Str dot. And you see a lot of options. Capitalize. And here you are. You can simply print it, or you can put it in format, and then you can do that also. That I'll show you. So we are running for the first time, so it takes time. Okay. So you can see that welcome to the world of computing. Only first alphabet of the string is capitalized. Now suppose if I have some string something like this, we have two sentences, and if I want to do that, I'm using format here to display original string and capitalized string with format. You can use it, or you can use a comma also. You can see that original string welcome, and this is W, but nothing else has changed. Only first alphabet of the line is changed. Okay. If I have some other thing, let me have another string, and I can have the same. Suppose it is a hash and it is not a string. I'll just copy it from here. Okay. So obviously it will not be capitalized. So capitalized nahi hoga. So what we have is if only the first alphabet of the line is capitalized, not others. So capitalize is there, but it won't actually capitalize everything. Then we have centering. Okay, that is not listed above, but we have it. Now let's just write the text instead of it already. Okay, so we have some string. We'll just put str is equal to put something like Python is put. Okay, and now new string I have to create. Str is equal to str dot center. This I have to give how many uh, characters you want, length of the string you can give. Okay, now print, let's say, let's check the length of str first, then print, you can print your length of the new string. string. New str. It is str, not string. Okay. Fine. Now you can print the strings. Print str and new str. I can use the format command also. And I can do that also. In format. Let's look better. Length of original string is this, and spelling of length is wrong, so I have to correct it. DPH. And I have to close the bracket. Length of new string. Let's put original string format. I have not put the uh, curly brackets. I have to put curly brackets also, otherwise it won't come. So I have to put the curly brackets here. Here also. I will just copy this. Label is always better because you don't know what happened. This is new string. For the sake of this display, a proper display. So length of the original string is 24, length of the new string is 24. Sorry, length of the original string was 14, length of the new string is 24 as we gave. And the original string Python is good, but you can see the space here. The space which is created. Okay, so the length was 14, so 10 on the left hand side has been appended. They are appended. The space is appended to the string. Okay, now let me copy this. And I know that it is 14. Now let me reduce it and see what happens. You have to play around things. And now I know that the length is 14 of the original string. Let me make it 10. Center 10. Let's see what happens. Okay, so Python is good. Original length and the length of the new string will still remain the same. It won't make any difference. There is no centering as such. If you give lesser size, then nothing will happen. If you give more, then it will be padded by spaces. Okay, there will be some spaces here and here also, on the left and the right. So they will be added. 5 on the left and 5 on the right, I think. It should be 5. Yeah. And then only it will be centered. Okay. So we have reduced and seen, and suppose I give more. You can see now the length of a line is 80. By default of a paper, A4 size paper, we take 80 columns as a size. So I have given 80 here and rest is same. You can see that it has moved a lot. So you can see that the total length is now 80, including 14 for the text. And you want to see that what happened actually. So what I can do is I can actually add a special character here. Let's say I will put hash here, hash star or whatever you want to put, and I'll make it 80 again. Choose no. Now I can run it. You can see. Now you can see clearly that it has been padded on left and the right with spaces. The new string is now padded. Okay. Now let's have case fold. Case fold. What happens with case fold? We'll see that also. Okay, convert to lowercase. Converts the text to lowercase. So we already have this text as the in the lowercase only. Let me put something new. Here is equal to. I'll put it in capital. Okay. Okay. Welcome to the world of AI. AI is fun. Okay. Now let's put CSTR. I'll take CSTR again. Is equal to str dot case fold. I'll just put the brackets and then I'll print the original and the and copy it from here. String, you can say case fold string. It is not new CSTR. STR, sorry, it is CSTR. CSTR. Yeah, it's okay. It's okay. Okay. So everything has changed. Now you can see that in capitalize only one alphabet. The first alphabet was changed, but here you can see that everything changes to small. It's a lowercase. So we can have a case fold like this. Then we have count. They're very interesting functions. So if you want to find it, oh, sorry. Number of times a substring appears in a string. So if I have a string, something like the above or something else, so I have a string. So let me get that. Welcome to the world of computing. It is almost the same thing. So I'll just put it. Yes, welcome to the world of computing. We are working on string functions. Right, I would like to have space. Now I have to find the count, but count of what? Let's see. Okay, count. I can see STR. I can give issues. STR dot count. Count the substring. The substring here. Let's say I take world. Keep in mind that I'm using world as small. Let me keep it capital first, and now count. So count will be your actually numbers. So, but still it's okay. You can have STR. So welcome to the world of computing. Let's see how many times world comes. It's only once, so it will be once. But what happens if I give it small w? This is the blue. This world is small. Okay. 0. it won't match. Okay, so it won't match. And suppose I give something which is in between, it is not a string at all, the complete word. Let's say it is an ending word. I will give ing. Suppose I give ing. Now what happens? Ing is here. It is not a complete word, but still it can find how many times ing came in the string. Okay, and let's see if in between I can get something. Or I can try that. Okay,
So can we count the spaces between two?
spaces also you can find here.
Okay.
Number of words you can count. Na? If you can find number of words, then spaces are always there. You can always count minus length करके. Otherwise you can find the spaces also.
Okay, sir.
Let's give in between. I'll show you not this one, but we have other also. Or see in between or you can have something like this. Working, we had word, working or was there, so it can find out that also. And as you try this, a space, and let's see what happens. It has 11 spaces. See, it can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Yeah, correct. So you can from this you can find number of words also. Number of spaces plus one.
Yes, sir.
Then yeah. So you can find that also. Let me see the worksheet. Count. And then we have a string function that is ends with. The functions listed above are not here. I'm just adding what I have not mentioned. Now, oops. Okay, this function returns true or false. Okay. Hmm. This function checks if the string ends with the given string. If I give a string and try to find out that the string ends with that or not, so I can check that. Let's have str as one word I'll take for now, and I want to find that f is equal to str dot ends with, sorry, ends with, let's say, all. Is all or not. In the end, I can check that. Print if that's okay. It will return true or false, so I don't have to just put it in the format. No, true. So you can see that it ends with all, ball. You can give whatever a l if, or you can try with something else also, and I can have more strings and check length. I can increase the length and then check also. I can have ball. Again true, and something not there. Let's say FOO doesn't end with FOO, so it is going to give me false. But if I have a bigger string, something like this, str is equal to football, hockey, cricket, football, hockey, football, cricket, football. Okay, so now if I find, yeah, Copy this one. This is true, but if I remove one football, the last football, what happens? It is false. So the string has to end with the substring we have given. So ends with. Similarly, we have starts with also. So you can use that, and you have expand tabs also in code. We have start with. Okay, 1 minute. Can take this sentence, same sentence I can take. I'll take this one. Collab is not showing me the commands today. Okay. Starts with FOO. Let's see. Yeah, true. Let me put the starts with. And again, it will give false if I give ball. And the same means we have to use the last one. If I left in the right, okay. I give ball here, so it will return false. It does not start with ball, it starts with foo. So I cannot take that. Okay, then we have something very interesting. This for you. We have something called expand tab. What it does, let me show you. It actually expands the escape sequences if present. Okay. And let me first get some sentence and show you. We already had this football now. I'll put some escape sequences, and let me tell you, escape sequences start with a slash. Okay. So let me have my collab. Where is my collab? Okay. We have something like this. The string we already had. Now we have escape sequences here slash f, then slash r, then double slash. Like two here, and let's have the new string. New expanded tab ETB. ETB. They are dot expand, and we have option. Yeah, it is coming now. Expander, what expand I want. I can simply just give it like that and print ETB. Don't have to give anything. Let's see what happens. Cricket and football. Slash R is not there, so you can see that cricket and football. Let me use some meaningful things. see what happens. There are different options here. Backslash, home feed, backspace, carriage return, new line, slash t is for tab. So if I give tab, there's a form feed, so you can have slash t, slash n, suppose we have, and the other one is double slash. So you can see this. Football, hockey, there's a tab, football, hockey, football, then slash n goes to the next line. From there it breaks. So on the first one, it was form feed actually. So it is normally used for the printing purpose. So it was not visible what we were trying to do. It just went to the last one, cricket, football. And the rest was just not there. And in this case, you can see this, what happened. It took to the next line, slash n, to the next line, tab expanded. So you can see this clearly in this example, right? So we have now encode, encode, decode, a lot of things we have. Options are there. You can see the form feed, what feed you want to have. Okay, so we have to see the syntax first and what we can use with this syntax. Okay, syntax like this. Giving given string dot encode, encoding is equal to encoding, errors is equal to error. If no encoding is generated, then it is a UTF-8. UTF is a type of the text returned Unicode. Okay, Unicode text format, 8-bit. 8 is 8, 16, 32, 64. We can have different bits. Okay, so there could be errors, the errors could be like this, back slash replace, ignore, name replace, stick, and so on. So they could be more. Okay, so let's see. And thing we have, let's all and click str is equal to Python is 1 apply code is equal to str dot encode. Put type of encoding I want. I'm not sure if you have used any encoders. Online also we have many options. Use that also. By default, if nothing is given, then UTF-8 is used. As I told you, there are different ways of doing things. And errors is equal to strict. So this is what you have to give. Strict already explained above. Default raises an error on failure. That is, if error is there, it should be there, displayed. Now let's see what happens when I encode this. Python is fun. There's some error here. Let me see. Error. Oh, sorry, my spelling mistake. Errors. See, we just get a B. That is always with your binary. It gives adds. If it is a UTF-8, it adds B to the string. But doesn't make much difference actually. Won't make much difference as such. Let's see. I'll put another example and I'll put some special characters here. Python, or you can see that it is different. Unicode. Okay, so we are using Unicode, we know that. the string, print the string, the original string is there, and then encoded string is there. UTF-8 again is Python. You can see that pipe broken down, encoded. You can see that encoded into UTF-8. So it has changed, and this is what expected from this. Now let's see the other options we have with errors. And now this time encoding I'm using is ASCII. Okay. Earlier it was UTF-8. You could have tried with UTF-16 also, but it may not work. 16, 32, 64. Python, you can see.
Sir,
Python. Yeah, it has changed
uh,
into ASCII. Uh-huh.
sir, could you explain again what does that errors mean?
Errors. That is what I'm telling you here only. यहाँ बता रहा हूँ. I'm telling you. I'm telling you with example. See, it backslash replace. That is, uses a backslash instead of the character that could not be encoded. Okay, so if something cannot be encoded, then backslash you'll get a backslash. If cannot be, if it cannot be. If I say ignore, you can see that Python. This is ignored. This could not be actually detected because this is not actually an ASCII number. This is not ASCII. This is UTF. Okay, Unicode. This is a Unicode. You know Unicode. Do you know ASCII? Do you guys know ASCII? ASCII. ASCII के बारे में पता है?
No, sir.
I'll no. I'll tell you. Then let me add it here. ASCII is American code, American standard code. Sorry, American standard code for information interchange. That is ASCII, and I think I have 6. I put it in a code actually. Let me drop this. That's why it was giving me error. I had to put the text. Okay. This is ASCII American Standard Code for Information Interchange. I have not capitalized that. Okay, I have to. And this is what we used to have. And we have 0 to 254. 255 characters are there. Character sets are there. And in this we have capital A, capital Z. This is 65 to 90, small a to small z, 97 to 122, and 0 to 9, that is numbers, 48 to 57. Rest are special characters. 0 to 9. Rest are special. So this is your ASCII. Now, what happened actually? This has 255 characters only, but these are not enough actually. If you talk about, let's say, Chinese, Japanese, and all, they are covering only this ASCII covers English. Okay, these are not nothing to do with your Hindi or other languages. 1 minute, let me give a space. So, to actually take care of every language, almost every language, Unicode was designed. Now, why Unicode? Because in Chinese or Japanese, you see the interesting structures you have. I don't call them alphabets. I can't call them alphabets because we are not used to such things. So the designs we have in Japanese and Chinese, they are actually your words alphabets, and in some cases their sentences also. If you have watched some Chinese or Japanese movies, you must have seen that, or even in the Korean also, right? So you can see that. Now these sets, character sets in our language, let's say if in Hindi we are talking about Hindi, Devanagari has 49 alphabets and three, four, five matras. Okay, and similarly English has 26 alphabets, and Urdu has, I think, 42. Yeah, 42. Right. So we have limited character sets, and they can be easily taken care of by ASCII. But when it comes to other languages like German, also no issues. German, French, Spanish, they're similar to English. So the character sets are similar. But when it comes to these languages which have actually beautiful designs as alphabets or words, you can say, so it is challenging. So in that case, we have Unicode. Unicode, and you will be surprised to know that Japanese and Chinese, we have just limited 42, 45, maximum 50 alpha, alphabets. They have 60,000 character sets. One language would have 60,000 character sets. So, to cover that up, Unicode was designed, which has 65,656 character sets, which covers almost all the languages, not all the, you can say, alphabet or the words or alphabets, but maximum, so that you can actually combine and get what you want. So Unicode is huge. So UTF is Unicode. Basically, we use UTF-8 and Unicode when we say, or we can use ASCII. So encoding is ASCII encoding. We have different encodings, okay, and decodings also. So here we are using ASCII, and we want to encode this Python, which is actually O is not listed, which is not an ASCII character. You can see that it is not an ASCII character. So when it is not, and I say that backslash replace, that means if it is not, then just replace it. And Unicode, we have, you can see that Python, this it has come like this. Okay, so it is replaced by a backslash, and the character it must have returned, and then we have in the next one we have ignored. So if you ignore, then nothing will come, or will be omitted. And when I say name replace, that is Latin small letter O with diaresis, okay, slash n. And you can see that this is Latin. It says that it is a small letter O. Okay, so we are replacing with this. It just replaces automatically whatever I give. I can use some other character also. And in this case, errors replace. Then if not is if just I say only replace, then a question mark will come. You can see that Python, a question mark will come. And if I say XML character reference replace, then it will be converted into XML form. So we have XML also, the format like this. So it will be replaced. It will change according to the alphabet. Okay, whatever we have given here, it will change accordingly. So encoding will encode, and we have decode also, but we have encode, which you can use UTF-8, or you can use ASCII and see what happens. I can try this with UTF-8. Let's see what happens. Instead of that, yes, I can use UTF-8. I used it here. Nothing is given. It is always UTF-8 by default. If I don't give anything, but I'll give it. Right, let me replace this UTF. UTF-8 and UTF-8. All right. That's not it. See what happens. Convert it. It will be same everywhere because now it has actually got it. It knows that this is the code for O. This is the Unicode for O. So whether you replace by with a backslash or if it is an error, there is no error actually here at all. In this it was, but not in this one. So this I copied, but I changed the other one. Now, okay. So UTF, if there is no error, nothing will be replaced. It won't be changed, or it won't change. In this case, it does because it had an error. Okay, so error means it cannot be decoded. This is interesting now. We have another one. If you still have any doubts, you can always drop a message. I'll tell you. If you try and experiment with it, you can use special characters also and check what happens with the special characters. Special characters are in ASCII also, so you should not create any issue. So find actually searches for a substring in a string and returns a boolean that is true or false. Boolean is always true and false, true or false. Rather, sorry. Let's see. Now, str is equal to we are having fun with Ethan with AI using Python. Okay, let's see what we get, and we find it. Let's say f is equal to str dot find, and I want to find suppose AI and print 23. It returns the place. So it has returned the place for me where it occurs. So find will tell me it if it is a number. If it is 0, suppose it should return a boolean actually, but it's okay. If it is returning a number also, that is okay with me. I'll tell you how I can use it. I give something which is not there. My minus will be there. So what I can do is I can use this one. Print what I'll use here. If 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 is less than 0, then we can print, sorry, print not found, so string not found, else we can give here substring found in the, okay. This is how you can use it. So it doesn't actually return boolean, but it returns -1 if not found, or positive. Substring not found. That is how you can find out. Okay. We have other ways also. Very simple ways in not in like that. Let's try with something else and let's see what happens. The code. bit of string rather. Let it be, let it be, let it be. You can see that let it is 11 small minus 1, that is it was not there, and substring be contains substring be. This is how I used if code dot find. This is the code, and code dot find be not equal to -1. It is not equal to is this. Okay, you can always get that. You can find now if you want to format we have already done, so I won't be taking that, but I can use few more things. Okay, I'll take it. Take format because we have few things here interesting. This is we have already done actually with the string, but let me show you something. Okay, suppose we have a string here, str. I'll make it str. I'm using standard str. Hello, n is below 10. Then string str format. What is this? 0 is str and 1 is n. Okay, so if n is 10 number, something like this, we can always print string in the number, we can print that we know. Now let's have something else. This format abc, abc, and then abc again, changing the sequence, unpacking, and you can see that. You can see first one is a, 0 is a, 1 is b, and this is c. You don't give any numbers, abc by default. If you change the sequence, then 2 will be c, because the indexing is from 0, so a will be 0, b will be 1, and c will be 2. So if I change the sequence, this is how it is going to come. And if I unpack this, I want a, b, c together, and I just put a star. Again, it depends on the number how I have placed. It will be displayed like this, and you can have 0 1 0 dot format APRA and CAD. If I give something like this, Abra and CAD. Okay, there are two I have given, so you can see this abracadabra. I can print like this abracadabra. See 0 1 0. 0 is replaced by abra, and 1 by scad, and again 0 by abra. So abracadabra. This is what you get when you format. So you can format like this also, and we can have something coordinates like longitude, latitude with numbers. I can have like this, latitude, longitude, variables only, nothing more, nothing as such. So you can use it like this. Now we have another command called index. Index with the round bracket because it is a function. Functions are brackets. Okay. Function it again finds the substring and returns the index value. Substring in a string and returns the index value. Here is equal to, as we did earlier also, Python coding is fun, or coding in Python is good. Coding in Python is fun. Let's see, R is the results, str dot index. We have to find, sorry, we have to, we have to actually find something is fun. Suppose I'm finding is fun. So now I can print original string. I can do that, or I can find the results. Rs substring. I can give is also. Suppose I have to give this like is. So what I'll have to do is have to put them in double quotes. So if I want a single quote in between, then I have to give double quotes. Okay. So is fun is at index 17. That is from where it starts. That is, you start the indexing from 0. Those coding C will be 0, then 1, 2, 3, 4, 5, then spaces also counted 6, 7, 8, then again space 9, 10, 11, 12, 13, 14, 15, 16, and I is at location 17. Okay, it will just give you. We have some variations here, so let's see. We'll put that. We'll find the length and the coding. Python programming is fun. L is the length you find, then you print the length, then sentence dot index ing comma 10, then 10 minus 4, that is from the reverse. We are just finding the length for just to print the length here. The total length is 26, so that we can find out. So ing as at location 15, then G is at starting from 10, and that is you go on the reverse order. -4 will be in the ascending order, 10 to -4. If I give -4 to 10, it won't be able to find. And then 7 to 26, again in ascending order. So where it finds, it will give you the number. And this, if you give 2, that is start and the stop. I'll just give this start. In the start, and -4 is the stop. -4. So from the right, if I say see, dot will be -1, then -2, -3, and -4. So f ends at -4. So between 10 and -4, it will look for the substring. We can give a start and end. Then we have another function is alphanumeric, and again returns boolean, and it will tell you that, okay, sorry, here you are, I have given in the wrong. So if the number is alphanumeric or not, you will see that alphanumeric is a string which has numbers also. So Python is fun, that's all. And we will just check ch equal to s, use str dot is alnum there. Oh, sorry. Didn't see it. Sorry. Let's see what we get. False. It does not exist. There is no alphanumeric here. Alphanumeric should have a number and a string, or even a number only. 1, 2, 3. Python is good. Let's see if it can find that. Just put it, copy paste. It does not have. Why? I'll show you why. Find it. Let's have it something like this. It is true now. Why? Because earlier actually it was a sentence and it is a word. So it is looking for alphanumeric word. So if the word is alphanumeric, it will return that it is alphanumeric. Or if it's just an alphabet, we have is alpha is alpha, yeah. I can use the same one. What is checks the alphabets and it turns again a boolean. Use it with the if else also. Just giving you how it can be done. Show you. It can be put this. Is we have suppose s is equal to Python, then if s dot is alpha, then it is an alphabet, otherwise it is not an alphabet. So you can give something like this. Or if it is like what we had earlier string, like we have an alphanumeric string, what it will show instead of true false, you can display actually give your things. So now s is 99 Python, which is actually not an alphabet, which is actually your alpha numeric, so it won't give that as an alphabet, even though there are alphabets in it, but it won't show, right? Numbers also it won't. Then we have is decimal. Is decimal we can have like this. Okay, so we have an example here. Number which has to be number. Let's say we have a number 434266 n. If I check if n is decimal, then it is a decimal value. Otherwise, it is not. Decimal doesn't mean that it has to be a dot point. A number is treated as decimal also. But if it has, let's say, string also. So let's see. It has characters, okay, not a decimal value, because now it is 434266 QWERT, which is actually not just a number. So we have this thing. Then we have a digit also. It is similar to decimal value. Digit is digit. Okay, it's similar to your decimal. Actually, play around with the same thing. I'll just copy it from here. Instead of is decimal, I'll put is digit. There are certain similar functions. There is digit. So 434266 is a digit. So it will show you that it is a digit value. And if I give something else, let's see. Suppose sometimes we have numbers like this with a dash in between. So whether it is treated as a number or as a in decimal or not, it is not. So it is not a digit. So I have given a decimal because it becomes a string. You can check the type. Right, again one decimal. This is a digit. Okay, fine. So if we are giving number with some string, you make it alphanumeric, so it won't take it. Now we have is identifier. You have to see whether it is an identifier or not. For identifier, actually one word has to be there, only one word. The one word you have to give, and I'll now put it in the print statement itself. Suppose N is institute and the input string is an identifier. You can see whether it is or not. It will return a boolean, true or false. Now suppose I give a bigger sentence. Okay, you will understand what identifier is. Now I have given Institute de Informatica and I want to check whether it is an identifier or not, and it will tell me that it is not, because it is not a single word. Identifier has to be single word. Okay, so we can have something now. Suppose we have dashes in between. That becomes one sentence, one word. Sorry, but an identifier, it is not, because there are special characters in between. Again, it will not take. Now, suppose I take some special character again. Exclamation I'm putting. Let's see whether it is or not. Again, it is not. So identifier should be having pure characters only. Let's have a space and check whether it is an identifier or not. Obviously, it is not. It has to be false. Okay, so identifier will check whether the given input is a pure integer string or not. Then we have something called is lower, is upper, like is upper, is lower. You just have to check whether the given string is in lowercase or not. So we have something like institute, suppose, and I is capital. If I check it, it will give me false. The same if I give I also small, so it's okay. And let me change the string and let me make a bigger one. And Python is, let me make it capital and then I'll see it's false. Okay, because P is capital, so it cannot take it. So make P small. You can always club it with if else. That is true. So every character is true. And suppose let's try one more thing. Suppose I give F capital, anyone capital, it is again false. So every character in the string should be in small. Then only it will come. Okay. Then we have things to check numbers also, like decimal. We have number is numeric, and it is number or not. It checks that. So we can have something alphanumeric. If we have it won't work. Returns boolean. Different functions for the same thing. Okay, 1, 2, 3, 4 is numeric. That is true. Now suppose I change the number. and I put alphabet here, Z. False, because it is not a number. So we have three functions here, which can actually tell you what type of number it is. It is number or not. This digit was also there. Okay. Is printable. The function checks if the input is printable or not. Now, why will I think that the string is not printable? For this, I'll give you some strings. Now, S is hello. It's fine. The other one is slash with slash in. That is a new line. Slash T is a tab. Then we have a number, and then we have a string. Python is a very easy language. So let's see whether it is printable or not. And the return thing will be boolean, true or false. Hello is printable, fine. Hello is printable, false. It is not because there is a slash in. Hello is printable, again slash because slash t is there, it's false. Then space is okay. 123 pi is okay. Everything else is okay. But if you give a spatial, if you give a skip sequence like slash n or slash t, then it is not printable. Okay, so you can check if someone has given a slash t, a skip sequence, so you can use it and check it. We have a function which you were asking is space. So it actually checks whether there is a space or not in the string. If there is no space, it will give you. And if there is space, then we have some example here. S is equal to space. There are two spaces there. Then checking. Then S slash T also again space space. Everywhere I have given space. You can see that. Slash T is tab. Slash N is a new line. So you can see that all are true, but the last one is slash N. That is a new line, which is not a space. Okay. So in between, let me check this one. If it is not a space, okay, in between it is not checking. Let's see. Python is fun. Let's see whether it is a space or not. It will return false. It is not a space. If we are just checking whether it is a space, just a space, then you can use this. Then we have a title thing. Is title case is a format in which the first alphabet is capital. We have in Word also. Very simple way of using. So we have a string S is equal to Python is an awesome language. You can see that P, I, and A are capital and rest are not. So if I want to check it, it has to return a boolean and it will give me that it is false. Now, what is the title case? Let's see. I'll just paste, since it is already there, I'll just paste it and let me make it title. A and L. Okay. Now it is true. So every uh, first alphabet of the word has to be capital for title case. If you want to say see or if you want to check whether the given string is in title case or not, you can use this. Okay. Try this out. You can play around and check. You can check with ASCII. If you put some ASCII values, what happens? Like this. Again, it returns true because it is checking for the alphabets. So it doesn't matter that it has as sorry, special words. Special characters are there, doesn't matter. Now suppose if I give everything as capital, that is actually not a title case, so it will return false. It will return true only when each first alphabet of each word is capital. Otherwise, it will give you false. Special characters doesn't matter. So we have for the above example, we have is above, is upper, like we had is lower, we have is upper. So it checks for the uppercase. The above example, I can use this, and instead of this one is title, I can use is upper, and now this time it is going to return true. So Python is capital, and now if I find is upper, so it will give me that it is true. Okay, but if I give something like this, a title case or something like Python is fun. Sorry, returns false. Right. Let's try with something else. Again, it will return false. On the Python is capital, so it is not just checking the first word, it is checking everything. So let's try something else also. Let me make the title case. Let's see this one. Again, false. This is again false. Okay. I think I'll have to give you a pause. There are a lot of functions which we have covered. Just have a look at them. There are certain here which I have not listed. There are many functions. I have taken only the important one, and a few more I'll be taking, and then you can see that there are more functions here. We'll see what all we can take up. I'll just justify, or we have not taken that. Lower, upper, we have not converted. So these are the actually things I have not taken. These are some few of the examples we have taken, and that's very simple to use. Very handy tool. String functions are important. So for any data manipulation or analysis, you would be requiring them. So just we'll take a small break for 15-20 minutes, and we'll just so that you can go through it. I'll let me first save it. Let me first save it on GitHub. If it is on, then it will go there. It's very simple to save. Okay, let me share this with you guys so you can go through it. I have to take a small break now so that you can have a look, because I've taken a lot of the examples, but you have to practice them also. I have put it here, and then I'll put it in the group also. Okay, so I can stop the recording now.